Welcome to our 1.3 video on deductive reasoning. The essential question is, what conclusions can we make using the laws of detachment and syllogism? So let's find out what the laws of detachment and syllogism are. But first, deductive reasoning. Deductive reasoning is the process of reasoning logically from given statements to a conclusion. The law of detachment says if a conditional is true, its hypothesis is true, then its conclusion is true. Our notation for that is P implies Q. We know P is true. The three dots mean therefore, so then we can say therefore Q is true. The law of syllogism says if P implies Q and Q implies R are true statements, then P implies R is a true statement. So this is if P implies Q, Q implies R, then P implies R. Let's look at some examples. So example 1 says a gardener knows that if it rains, then the garden will be watered. It is raining. So this is looking like law of detachment. We have an if then, P implies Q, and we know that the hypothesis of the if then is true. We know that P is true. So therefore we can conclude that the garden will be watered. Okay. So that's using the law of detachment. One way we can be alerted that it's a law of detachment is that law of detachment often only has one if then statement. We will see some compound statements where we're using both of the laws together, but if it's just law of detachment, you'll only see one if then statement. Law of syllogism will have two. Try now, pause the video and give it a try. Okay, so this one says if angle A is acute, then angle A must be less than 90 degrees. And we know angle A is acute. So again, here's P, here's Q, and we're told that P is true. Whoops. We're told that P is true. So therefore, law of detachment says we can determine Q, which is the measure of angle A is less than 90 degrees. Here's another little bit more complex try now. Give this one a try. Pause the video. Okay, this one says, if a baseball player is a pitcher, then that player should not pitch 2 games in a row. Vladimir is a pitcher. On Monday, Vladimir pitches a complete game. What can you conclude? So we know, right, P, if a baseball player is a pitcher, and Q, they should not pitch 2 games in a row. We know that Vladimir is a pitcher and that he has pitched 1 complete game. So we know that he shouldn't pitch 2 complete games. So therefore, Vladimir should not pitch a full game on Tuesday, the next day, because then he would have pitched 2 complete games. Good. Next, we're using the law of syllogism. Example 2 says, use the law of syllogism to draw a conclusion from the following statements. If a quadrilateral is a square, then it contains 4 right angles. If a quadrilateral contains 4 right angles, then it is a rectangle. So if we label this, here's P, our first hypothesis, here's Q, our conclusion. We see Q showing up again here, right? Contains 4 right angles. So here's Q again. And now we have a new conclusion, R. So this is following, let's focus that. Come on. This is following our law of syllogism. P implies Q, Q implies R, and we know that we can conclude P implies R, which in this case would be if a quadrilateral is a square, that was P, and then R, then it is a rectangle. Here's a try now. Pause the video and give this one a try. Oh wait, there you can see all of it. So now pause the video and give it a try. Okay, so we see if a number ends in 0, P, then it is divisible by 10, Q. We see the same statement, if a number is divisible by 10, Q again, then it is divisible by 5, a new conclusion, R. So now we link P and R. If a number ends in 0, then it is divisible by 5. Okay, one more try now. Pause the video and give this one a try. Okay, this one says, if possible, state a conclusion using the law of syllogism. If it is not possible, explain why. So if a number ends in 6, that would be P, our first hypothesis. Then it is divisible by 2, our first conclusion. If the number ends in 4, do you notice that something? Usually, the conclusion of our first if then is the same as our hypothesis of the second. This is new. We'll call it R. Then it says, then it is divisible by 2. Q. Because it does not have the right structure, we cannot conclude anything. Our if-then statements have to be in that structure. So this would be no conclusion. They're not in the right form. Lastly, we've got one complex piece that we'll put together that includes the law of syllogism and the law of detachment together. So this one says, if the circus is in town, then there are tents at the fairground. If there are tents at the fairground, then Paul is working at the as a night watchman. The circus is in town. So first we're going to use the law of syllogism, and we're going to say P implies Q. We see that Q again as the hypothesis of our next if-then. Then we can imply R. So we know that we could rewrite the first two parts using the law of syllogism as P implies R, which is, if the circus is in town, then Paul is working as the night watchman. We know the circus is in town, so we can use the law of detachment to conclude R. Paul is working as a night watchman. Okay. Now we have try now 3, using the law of detachment. Pause the video and try this one. Okay. This one is a tricky one. Couple things. First, we would want to switch around the order that we read these. If we read it just straight down, it's kind of confusing and it's hard to figure out. But if we read it backwards, if we read, if a river is in Europe, then it is less than 23 miles long. If the river is less than 23 miles long, then it is not one of the world's longest rivers. We can see P and then Q. We see Q showing up again. And then we see our new statement R. So using the law of syllogism, we know if the river is in Europe, P, then we can conclude R. It is not one of the world's 10 longest rivers. We're also told up here that the Volga River is in Europe. So we know the hypothesis is true. We know that the river is in Europe. We can conclude R, that it is not one of the world's 10 longest rivers. And it is also less than 2,300 miles. River is not the world's 10 longest rivers. Okay. That is all for our 1.3 video.